And I would like to hand it over to our colleagues from Digital Petroleum, Nikita Klyuchnikov and Dmitry Koroteev, that will tell us about AI drilling to control risks at drilling wells. Nikita, over to you, Dmitry. Thank you, colleagues. Today we will tell you about a specific project in Digital Petroleum on AI drilling system. That's the product to control risks and do the forecast for some terms of complications. I'm Nikita Klyuchnikov, a manager from Koroteev, expert on machine learning in Digital Petroleum. I am a director of Digital Petroleum and a Koroteev professor. It's good that we follow AIJ, because AIJ told about the specific features when you build modern wells. Today, you should know that it is expensive. It's an expensive arrangement for oil and gas companies. So they are built vertically with a horizontal shaft. And the construction process can take months, and it also depends on the design of complexity in a well. And the budget could be from dozens, millions to billions. Any emergency would be a serious problem, and it may cost $20 to $30 million to do the maintenance. To avoid failures in all major oil and gas companies, there is drilling follow-up center with experts from drilling and subsurface. They look at telemetrics of drilling, and the main problem is that one expert has to monitor a number of wells being drilled in real time, graphics on telemetrics, and there is a serious burden on one expert, and the risk is that the expert can ignore indications for an emergency, and the company can have serious financial damage. And financial damage can not only be about money, but in a lot of downtime at well construction, and downtime means more time till the first commercial oil is produced. So our system helps to analyze telemetrics for drilling in real time, backlogging data, the geological and technical information in Russian, to support the drilling process and make it as automated as possible. Now I would like to hand it over to Nikita, so he will tell you about the system, how it's designed and how it works. Hello. I would like to give you one case we chose for developing the system. It's called classification of time series based on machine learning. And there is a funny case. One colleague designed an access permit system for his cat and his house, for the system to let the cat in when he comes with a mouse cord. So he marked some situation with the cat in process, and so he used that case to learn the assisted drilling system. And there were some cases with emergencies, like stuck mud loss, fluid show, washout, and so on, and normal situation. And also they marked them in the system based on time series. To use source data, we have 12 time series. You have actually at every well, like rotary speed, hook load, progress volume. After we gathered that situations from a number of wells, we collected the data set with over 2,500 of situations in operating modes and about 1,500 cases of emergency situations. So this is how the standard modelog data looks like. And in red, you see the point of complication. And at the right, you see the forecast with a probability for a certain type of complication. So we see that it actually worked in several hours before the accident. So actually it can warn the operator on the probability of an abnormal situation. For our approach, we used the classical machine learning approach, bag of features. We chose it because the data set is not so deep and so broad. It was not possible to use the standard machine learning models. The chance is high they would not have enough data. And here we use the higher chance of control. We used images, but the same approach could be applied to time series. The image was cut into a number of bits, and then they were used for calculation. We had a number of patterns which are often, and we can define what's the class of image or accident is present there. A little bit more about the time series. We take little bits of data, like for 80 minutes, and we do the integral transformation to get rid of interferences and to get higher stability for different deformations in time. It can happen quickly or faster, and we see the number of attributes, and then we classify them by clusters, by groups, and we use clusters later on. Then we take a window of 1 hour, and we can define it cluster by cluster. How many little bits are there in one window. And based on this histogram, it's possible to train the model the type of situation at well, what happened during the past hour. So to adjust the system, you have a number of hyperparameters you can define. The process is lengthy, and it would not be practical to make amendments, so we divided it into 2 groups. Group 1 is for the window, where you have bags and bits of time series. We use to identify the type of the cluster. And for them, we use a number of combinations from clusters like wavelets and the levels of decomposition, so time transformation. And then after we identify the best possible parameter for step 3 and 4, using the external clusterization assessment, yes, we identified a number of groups, and manually we classified what's possible and what's not, what would fall in one cluster and what won't. And our clusterization allows manual splitting, and we identified hyperparameters. And then we do the evaluation based on ROC-AUG model that would show the number of right cases for the classification. We also tested another approach. We trained neural network, a model that can learn how to classify things that happen in real time. It's better than the previous method, like early detection signals for accidents. And then I would like to conclude my last slides, and then I will hand it over to Dmitry. Oh, actually, the system is successful. It works, it operates in a number of companies, and we see that algorithms within the system still have room for improvement, and this is what we do continuously. But even today, I can tell you about some unique features of the system itself. It's fully automated. You don't need to type in anything manually. It connects to the data stream with SML in real time. And as Nikita said, the system doesn't need the drilling rig to be high-tech. It analyzes all data that are recorded even on old drilling rig. And it increases operators' maintaining capabilities if he runs a number of wells, so it can give operator the hint where is the problem. So the operator doesn't have to have all the wells in his mind. The system is not just algorithm, but it's a full-scale cloud solution with its interface, with the possibilities to download reports with the data. And the system is easy to use. Dear colleagues, we are done. If we have more time, we are ready to answer your questions. Thank you, Dmitry. Thank you, Nikita.